Hello students, welcome to Hari Chemistry. So myself Dr.Hari prasad. So today's session we will discuss students. So this is the group 3 acidic radicals. So these group 3 anions are sulphate, phosphate, borate and fluoride ion. So you can remember as SP Balu, right? He's a folk singer like that, you can remember student. So that will be easy tip, okay, right. So actually this is the third category of acidic radical student. So usually we studied group 1 radical and group 2 radical, group 2 acidic radical and group 3 acidic radical. So group 1 acidic radical student, so which gives a volatile product with the diluted acid. So group 2 acidic radical which give the volatile products with the concentrated acid, and the group 3 anions which does not give, which cannot give volatile product by adding diluted acid or concentrated acid, right? Okay, now in this group 3 anion students, we will discuss the preliminary test of sulphate and confirmatory test of sulphate and phosphate, borate and fluoride we will discuss student, right? So this topic is very important student for G mains and advanced level as well as NEET aspirant student. So generally regularly each and every year advanced paper 2 to 3 questions are coming from the salt analysis student. So maximum factual questions, only theory based questions are coming here, right? So just read the notes, right? Watch the video and copy the notes and practice once twice, then it will helpful to you, right? Okay, so please subscribe the channel student. If you are watching the first time, I am very requesting, so please subscribe the video and like the video, and it will reach more number students. So how much efforts we are giving, so just we are requesting for only one like or subscribe student, right? Thank you very much. Now we will enter into the topic right now. So this is student test for sulphate, right? Okay, right. So here we will discuss preliminary test student, right? So now take a original salt, right? So add few drops of diluted HCl and heat the content, boiled the content by using the Bunsen flame, right? So after heating student, so use the test tube, use the filter and using a filtrate paper, and this solution, this heated solution, hot solution, you can pour student, so then you can separate and you will get the filtrate, right? So you will get the filtrate, right? Now look at student, so this filtrate, so you can add barium chloride solution, you can add student, so barium chloride solution, right? Now this barium chloride, so react with sulphate ion present, so this Na2SO4, if sulphate ion present, it will reacted with the barium chloride solution, so this will form a white precipitate of barium sulphate, and so formation of 2 sodium chloride, right? Now this is a white precipitate student, right? Now this is a white precipitate. Now this white precipitate student, so it is forming a white precipitate, right? Now this is a, right, so it will form a white precipitate, right? Now this white precipitate student, so you can add concentrated HCl, you can add student concentrated HCl and shake the contents of the test tube well. So the white PPT, this white PPT is insoluble, this white PPT is insoluble in concentrated HCl, in concentrated HCl, right? So which indicates student the sulphate ion is present in the given salt, right? Now this is the preliminary test student, right? Okay, now look at student the confirmatory test for this sulphate ion student. The first test is what student? Barium chloride test, right? Now so look at student, so take a test tube, right? So add aqueous salt solution, take aqueous salt solution, right? Add barium chloride solution, barium chloride aqueous solution, right? Now this salt solution react with barium chloride and it will form a white precipitate. So that means student, so Na2SO4 reacted with barium chloride, so then it will form barium sulphate as a white precipitate student. So barium sulfate as a white precipitate. Barium sulfate as a white precipitate, right? Now, so this white precipitate, student, you can add diluted HCl, right? So shake the test tube well. So the white PPT, shake the test tube well. The PPT is insoluble. The PPT is insoluble in diluted HCl, right? So this is the confirmatory test of sulfate, student. This test name is called as a barium chloride test, right? Next, student. So we will move to the second test, student. We will move to the second test. The test name is called as a lead acetate test, right? Lead acetate test. Lead acetate test, right? Now look at, student, how to do this lead acetate test, student, right? Now take a test tube, student. Now take a test tube. So this is our clean and dry test tube, right? Now, so this test tube, you can add, student, aqueous salt solution. Aqueous salt solution. Okay, right? Then add, student, lead acetate. Then add, student, lead acetate, right? Now, student, this lead acetate react with the salt which containing SO₄², right? Now it will form, student, a white precipitate of lead sulfate, right? Now this is, student, lead acetate PbCH3COOH twice reacted with, student, the salt containing sulfate ion. So it will form, student, lead sulfate as a white precipitate. Lead sulfate as a white precipitate, student. Now this white precipitate, and so byproduct is, student, so 2 moles of CH3COONA, right? Now look at, student, this white PPT precipitate, you can add hot ammonium acetate. Add hot ammonium acetate to the above white precipitate, student, right? So this white precipitate is insoluble, is soluble. This white PPT is soluble. White PPT is soluble in excess of soluble in excess of hot ammonium acetate. Hot ammonium acetate, right? So this is about, student, the lead acetate set, and this is the confirmatory test for sulfate ion, right? Now look at, student. So we will move to the, in this category, the third is, student, this is the second is, we will discuss test for borate. We will discuss, student, test for borate, right? Test for borate, right? So this is called, student, it is orthoborate, right? Now this will be O minus. This is called, student, orthoborate. This is called orthoborate. And one more also is there, student, that is called BO₂-. This is called as a metaborate. This is called, student, metaborate, right? Now this orthoborate, student, right? So now the salt containing this borate, so then you can add, student, concentrated H2SO4, right? Concentrated H2SO4, right? Now after that concentrated H2SO4, student, then what will happen, student? So for example, if I am taking this, right, so this H plus will added here, this H plus will be added, and it will form, student, orthoboric acid. So this will be formed as a orthoboric acid. It will form as a, this is formed as a boric acid. It will form as a boric acid, student, H3BO3. Now, so this boric acid, so you can react it with, student, ethyl alcohol. You can react it with, student, ethyl alcohol, right? Now this ethyl alcohol react with boric acid, and it will form OC2H5. So this will be BOC2H5. So this will be OC2H5, right? So this is called, student, triethyl. So this is called triethyl borate, or you can call, student, or you can call triethoxyborane. You can call, student, triethoxyborane, right? Now this is a gas, student. So triethoxyborane is a gas, right? Now, so you can use a flame, student. So you can use a flame here, right? Now you can use a flame here, right? This is a gas. You can use a flame, student, and it will burn, right? This gas burn, this gas we are burning by using the flame. It gives, student, it gives a green color compound, a green color. It will, the flame will be turns into the green color, right? So this will indicate, student, the borate ion is present in the given salt, student. This is the most important stress, student, right? Examination point of view, right? Okay, so this will give, student, so green color you can remember, right? Now look at, student. So, and one more test, student, you can check the second test for this borate ions, right? Now look at, student, take the salt which containing the salt containing borate ion, or which containing boric acid, right? So now look at, student. So add powdered C2F2, powdered CaF2. This is called, student, fluorospar. This is called fluorospar. This is the ore of fluoride ion, student. Then add, student, concentrated H2SO4, right? Concentrated H2SO4, and make as a paste. Make as a paste, right? So take one glass rod, student. Take one glass rod, right? So this glass rod, into this glass rod, so you can take the paste, student, and this paste at the end of this one glass rod, and so you can use this glass rod, you can put on a Bunsen flame, right? So it will burn with, student, green color. It will burn with, student, a green color, right? So which indicates, student, the borate is present in the given reaction, right? Now look at the reaction, student. Calcium fluoride reacted with concentrated H2SO4 and form, student, CaSO4, right? Now this HF gas is released, right? So 2HF, right? Now this HF is reacted with boric acid. This will form BF3, student. So this is a volatile green color, right? So, and formation of, student, water molecule. Formation of water molecule, student, right? Now this is burns with green flame. Burns with green color flame. Burns with green color flame, and it is a volatile compound. This is the second test for, student, borate ion. This is the second test for what? Borate ion, right? Now look at, student, this, right? So this is the test for borate ions, right? Now we will move to the third test, student. We will move to the third test. So that is a test for phosphate. That is the test for phosphate. PO₄ right? This is the test for phosphate. So this is P double bond O, O minus, right? O minus. So actually it is the, right, salt form of this orthophosphoric acid. Actually this is a tribasic acid, student. So this is the tribasic acid. It is a tribasic acid. It is a tribasic acid. Right. Now this is the right. Now look at student. In this particular reaction student. So take a test tube. Take a test tube. Add virginal salt. Add virginal salt. Then after student, add concentrated HNO3. Add concentrated HNO3. Right. So boil the content using the Bunsen flame. Boil the content using the Bunsen flame. Right. Boil the content. Boil the content using Bunsen flame. Boil the content using Bunsen flame. Right. Then add student. Then add ammonium molybdate. Then add ammonium molybdate. Ammonium molybdate. Ammonium molybdate. Ammonium molybdate. Right. So then on heating, so ammonium molybdate on heating, student, it will give a canary yellow color PPT of ammonium phosphomolybdate is obtained. So which indicates student the given salt containing phosphate ion is prasad. Right. Now look at the reactions of this particular compound student. Right. Now look at if the salt is containing phosphate ion. Right. So this Na3PO4 reacted with student. So this is concentrated HNO3. First we added concentrated HNO3. Then we boiled the content. Then after we are adding student. So this is ammonium molybdate. We are adding student ammonium molybdate. Ammonium molybdate. So this is MOO4. Ammonium molybdate. Right. So then followed by heating student. So we are getting a canary yellow precipitate of ammonium phosphomolybdate. Ammonium phosphomolybdate. So this is most important student. So this is ammonium phosphomolybdate. Right. So with the byproducts of ammonium nitrate and plus sodium nitrate and plus water is the byproduct student. So this is a canary yellow. This is a canary yellow PPT. Canary yellow PPT. This is a ammonium phosphomolybdate. So this is a ammonium phosphomolybdate. Ammonium phosphomolybdate adds a precipitate student. Right. Now look at student. This is the next test student for this phosphate. Right. So this is called magnesium mixture test. Right. So this is magnesium nitrate test, you can write student. So magnesium mixture test. Magnesium mixture test. Right. Very simple student. So just take a clean and dry test tube. Take a clean and dry test tube. Right. Now student, add aqueous salt solution. Add aqueous salt solution. Right. Then add magnesium nitrate. Add magnesium nitrate. Then add ammonium hydroxide. Right. Now this reaction, right, so keep the mixture, right, without undisturbed student. Right. Just after adding, just keep the mixture undisturbed. So then after some time student, it will form a crystalline white PPT. It will form student a crystalline white PPT. Crystalline white PPT. So that indicates student the compound containing phosphate is present, right? Now look at student, the reaction is what? So if the salt is containing phosphate, right? So now this is Na2HP4, so that is reacted with magnesium nitrate and followed by ammonia, or you can take ammonium hydroxide, student. So this will give magnesium ammonium phosphate. So this will form a white PPT. So this will form a crystalline white PPT. So byproduct is, student, so 2NaNO3, right? So this is a test for phosphate ion, student, right? The last category of this particular topic, student, so that is test for fluoride ions. Test for fluoride ions. Test for fluoride F minus ions. Test for fluoride ion, right? Now look at, student, right? So the test we will discuss, student, right? So first take a clean and dry glass tube, student. Add the virginal salt. Add virginal salt. So this is the original salt, right? Now this is the virginal salt. This is the virginal salt, right? Now, so this original salt, you can add, student, concentrated H2SO4 as drop wise. Then boil the content by using the Bunsen flame, student. Boil the content using the Bunsen flame, right? Then after some time it will produce, student, a colorless gas, right? It will produce a colorless gas, so which indicates that is HF gas, hydrofluoric acid. Now look at, student, for example, if the salt is containing F minus ion, so this F minus ion reacted with concentrated H2SO4, it will form HSO4 minus and HF gas, right? Right. Now, so this HF gas containing solution, student, add small quantity of sand, or you can write SiO2, right? Now, so this SiO2 adding, student, SiO2 adding, student, right? Then you can take one glass rod, right? Take one glass rod. So heat the content, student. So heat the content, right? Use the glass rod. This one end is you can put into the test tube, student. You can put into the test tube, right? Now, so this glass rod, so becomes a waxy, right? So this glass rod will be deposited as a white waxy deposited over the glass rod. So where the moisture is present, moist part of the glass rod. So then what is happening, student? A waxy type white precipitate is deposited on the moist part of the glass rod, student, right? Now what is happening, student? Right, now look at, student. So this HF reacted with SiO2, and form, student. So SiF4 and water, right? Now this SiF4 again reacted with water, student, and forms a waxy white deposited that will indicates student, this is silicon hexafluoride type of compound it will form, and followed by, student, H4SiO4. This is called, student, this is H4, student, this is H4. So this is called silicic acid. So this is called silicic acid, right? So this will form as a precipitate, right? So this is a silicic acid. So that will be deposited over the moist part of the glass tube, right? Now this is, student, the test for fluoride ion, right? Next, one more test is present, student. So now look at, student. So take a glass tube, take a clean and dry glass tube, right? Now you can add, student, sodium carbonate extract. You can add, student, sodium carbonate extract, and this sodium carbonate extract you can acidify by adding acetic acid. Acidify by adding, student, acetic acid, right? Acetic acid. Then heat it, right? So then you can use the Bunsen flame and heat it and to expel carbon dioxide. So to expel carbon dioxide, then add calcium chloride solution, aqueous calcium chloride solution, student, and it will form a white precipitate. It will form a white precipitate, and it is insoluble in diluted H2SO4. And this compound you can add, student, this insoluble compound you can add KMNO4, and the color of purple is decolored. That color will be not decolorized. Purple color, KMNO4 color, not decolorized. Now look at the reaction, student. Very simple reaction only, right? Now if the salt is containing fluoride ion, this will reacted with, student, CaCl2, right? Then it will form CaF2. So this, student, it is a white PPT. So this is a white PPT and plus 2 NaCl, right? Now this white PPT is insoluble in diluted H2SO4, right? Then add this compound is containing, so this compound is containing this fluoride ion. You can add, student, KMNO4, right? The KMNO4 purple color will be not decolorized, right? The compound turns into purple color, right? Now these are the test for fluoride ion, student, right? So these are, we discussed the total 4 ions, acidic radicals of the group 3 anions, right? Okay, so we discussed sulphate, we discussed borate, we discussed phosphate, and it. Okay, so sulphate we discussed preliminary test, student. So we have taken virginal salt, that is added diluted H2SO4, boil the content, then filtrate is added by the barium chloride, and it will form a white precipitate that is insoluble in diluted HCl. So just you can concentrate on reaction, student, right? Now then second test is, student, confirmatory test, student. So take the aqueous salt solution, add barium chloride, and it will form a white barium sulphate as a precipitate. Then add dilute HCl. This PPT is insoluble in diluted HCl, and it confirm sulphate ion is present, right? Next, lead acetate, student. So take aqueous salt solution in a clean and dry test tube, add lead acetate. This lead acetate reacted with the sodium sulphate, and it will form a white precipitate and allows sodium acetate as a sodium acetate, right? Now this white precipitate you can add hot ammonium acetate. This hot ammonium acetate adding, so this white precipitate is insoluble in excess of hot ammonium acetate. That indicates, student, thus a sulphate is present in that given compound. Next, so test we discussed, student, test for borate. So this is orthoborate, right? So our metaborate also present. Orthoborate reacted with the concentrated H2SO4, it will form boric acid, right? Now this boric acid, student, reacted with ethyl alcohol 3 moles, and it will form triethyl borate and triethoxyborane, right? Now this compound using the flame, right? So then it will burn with the green color, student. That indicates the borate is present in the given compound, right? Next, student, so you can take a salt solution which contain borate or boric acid and reacted with the CaF2, then add by the concentrated H2SO4, student, and make a paste and put onto the Bunsen flame. It will burn with the green colored, student. That indicates the presence of borate ion in the given solution, right? Now, so these are the reactions, student. So just you can follow the reaction. I hope you will get the answer, student, right? This reaction is most important, student. Just you can thoroughly revise, right? Thank you student. Thanks for watching the video. Right. So please like the video. I am requesting one and all student. So please subscribe the channel and please like the video. So it supports me so to make more number of videos student for your bright future. Thank you student.